So welcome back to the part 3 of experiment number 3 of ECD lab. The title was Layout Physical Verification Placement Route for Design Static Timing Analysis of Deep Flip-Flop. In the previous designs we find a bug in the design, and that's why we are not getting a proper output. So if we check the previous design, so here we are not getting a proper output Q and QM, and that's why here I just remove that bugs and I make a new design where you find we are getting that proper output waveforms. This is the same schematic, only we interchange some elements and we are having that some layout with respect to the clock and not clock, as well as that the D and the output of this particular CMOS inverter where we connect that D input, where we are also making that separate VDD for each NAND gate pair. So if we check the schematic and this particular design, so you may check it is same, it is identical. So your D input, this is a D input, is given to N1 directly, where for N2 it is inverted. At layout also you can find there is a D input which is provided directly to N1 and inverted output is to N2. That means it just look like S and R, where R is complement of S. Whereas the clock, the first master SR latch will get inverted clock. So the clock is here, their inverted or their output is connected to that the N1 and N2. The output of N1 is connected to N3. The output of N1 here it is connected to N3. The output of N2 is connected to N4. Then if we move here, the output of N3, is feedback to input of N4. The output of N3 is feedback to input of N4. Similarly, the output of N4 is feedback to N3. Output of N4 is feedback to N3, as well as the output of N3 is feed forward to N1 dash, the next slave latch gate, that is N1 dash and N2 dash. Output of N4 is connected to input of N2 dash, and the remaining thing is same. So here we connect the D, the input D, the clock we provide. So this is input D, the clock we provide. We have taken here the output at the master output QM and the slave output or final output, that is Q. And here we run the simulations. Let's check the output waveform. So if you find at the rising edge, we are making here that positive edge trigger. So at the rising edge, whether the input goes through your output Q or not, this is QM is intermediate stage, or we can say that is the output of master, and this is the final output. So let's check from the 0.3 nanoseconds at the rising edge. At this rising edge, what my D is 1. So at output it is reflected. For next rising edge, the input is 0, so it goes to output. It will take certain time, that is we can see a propagation delay. Now in between these two clock pulses, even if there is a change at input, there is no change at output. So it will hold the same beat or same state up to the next rising edge of the clock. So for next rising edge of the clock, your input goes to 1, so again the output also goes to 1. So it is exactly match to the truth table of your D flip-flop, or it works very well. So this is the D flip-flop. If you are taking the printout for your practical manual, so we just change here the color. We are going to that white background. We run once again the simulations, and here we just arrange or manage it. So we are getting this output waveform with this design. You can go for print screen, you can go for paint, you can do copy paste,